Today, class, we're going to go over Chapter 4, Section 3, which is functions in your book. What is a function? Basically, a function is a machine in which you put in an input and get out an output. The output is based upon the input and the rule in which the machine applies. For every input, it is important to know that there will be only one output. Putting in the same output will never get you a different output. The input and output can be both numbers and letters. From this point on, we will call the input x, the output y, and the rule the function. After we have put certain values into the machine, we will want to pull all the results together. There are multiple ways to do this, but the first way we're going to look at is tables. The table is split into x and y columns. For example, on the bottom, our rule is x plus 1. So far, our table we plug in any value for x and get out x plus 1 for our y. Then we put these values in the table. The other way to display function results would be in a graph. A graph is split up into two lines. The horizontal line is the x-axis, and the vertical line is the y-axis. We will take the example from the last slide to explain graphing. Let's take the first result. We have an x value of 1, so we go right 1 on the x-axis. We have a y value of 2, so from 1 we went right. We go up 2 on the y-axis. We get that point 1, 2. After you do this for all the points, you connect the points with a line. There are many important pieces of information that go along with functions. First, we're going to talk about domain and range. The domain of a function is every single x that can be used with the equation. The range of a function is every single y that can be used with the equation. For the equation we have been using as an example, the domain and range are all real numbers. On this next slide, I want to see if you have been paying attention and see if you can tell me from graphs and tables that I show you. On this slide, I show you two tables. Are both of these functions neither functions, or one is and one isn't? The one on the left is a function, even though the number 3 is used twice in the y column, but the one on the right is not a function because for one x there is multiple y's. Now look at these graphs. Which of these are functions and which of these are not functions? The ones on the left and right are functions, but the graph in the middle is not because it is a straight line up, meaning all y's are outputs for that x. Another important piece of information of functions is the zeros of the function. There are multiple ways to figure this out. The first way is to set the function equal to 0 and solve for x. For our original equation, the 0 is -1. Another way to tell is to find the 0 of a function is to where the line crosses the x-axis. All x's can be combined with other functions. They can be added, subtracted, multiplied, or divided. An example is shown on the bottom of this slide. All functions can be transformed as well. Combining functions transforms functions. Functions can move up, down, left, right, and grow and shrink. Here are some examples of some transformations. And here are a couple more. The last two pieces of information that are important are slope and y-intercept. First, we will talk about slope. Slope is the rate at which the function changes from input to output. Slope, therefore, can be called rate of change and also rise over run. The y-intercept is the point which the line crossed the y-axis. Now I'm going to show you the procedure to find slope. Slope is found by dividing the rise over the run. The rise is the change in y's, and the run is the change in x's. For this example, the change in y is 2, and the change in x is 1. So 2 divided by 1 gives up a slope of 2. Now, finally, I'm going to explain how to find the y-intercept. If you plug in 0 as an input, your output will give you your y-intercept. For this example, you will plug in 0 and get -4 as a y-intercept. Another way to find this is if you look at the graph and look where